Hey everybody, and welcome to day 4. I think it is. It's kind of like an ongoing road with no light at the end of the tunnel at this point. I'm pretty tired. It's getting pretty exhausting doing posters, so many posters every day, and I can say that a lot of you people agree with me, so I feel you're tired. I'm pretty tired too. Most people have gone home at this point. I get why. But today actually was a really cool day for a lot of the cognitive behavior and pharmaceutical work that I specialize in, and a lot of developmental work, especially in the morning. The morning had really a lot of great posters for my area of research. The afternoon had more molecular, cellular, and more anatomical focuses of visual pathways, attention pathways, and different behavioral pathways as well. Stuff I'm going to talk about is from this morning, though. The poster I went to was by Robin Gibb, and she did prenatal fluoxetine exposure causing a decrease in spatial working memory in the Morris-Water maze for fluoxetine-treated animals. And what was really interesting about that is that there was a poster along the way at a different location that looked at fluoxetine effects on maternal care of her pups. And so I thought I talked between the two of them, and it was really interesting to see them talk and collaborate and come to the idea that maybe the fluoxetine is affecting the maternal care of the animal, and the maternal care is thereby causing this decrease in Water-Morris maze rather than the fluoxetine itself. And they talked, speculating different ways to test that idea, looking at serum levels, all that stuff. So that was really cool. Another cool poster I saw was another cool thing that I saw in that area was they did, instead of doing the standard 5-choice animal model where an animal chooses between 5 different stimuli, and it's kind of to measure task choice recognition essentially, they made it one stimulus come on and the animal has to go and hit the stimulus, which kind of made it almost like a continuous performance task for mice. It would have been really interesting if they had like different color lights or different color lights that came up, or different stimuli that came up that the animal could detect, and the animal had to choose a correct stimulus. That way it would be like modeling the CPT in animals and seeing in mice to see how it affects the rat behavior. That was kind of cool, that they're kind of playing around with the models they have in order to come at very basic and different choices. Another kind of neat poster that I went to, it wasn't really super scientific, but it was really applied, and it wasn't the greatest of studies, but I thought it was really interesting. And they did a behavioral analysis on the go, no-go test on school-age children with integrated Buddhist education program. So the idea was that the children were meditating an hour before class, and then they had integrated meditation sessions, and they were taught basic Buddhist principles during the day on top of their normal teaching schedules, and apparently this increased their performance on the go, no-go task. So that was a cute little experiment. It wasn't well balanced for gender, and it wasn't a super rigorous study, but it was a really cool, neat little idea that I really liked. It would be interesting to see if they were a bit more rigorous with their testing parameters and balance for gender and other things like that. But I thought it was an interesting idea. Another really cool poster I saw that had a lot of interesting ideas and a lot of basic groundwork was cephalopod neurology. And this was from the University of Florida. And this girl was looking at the neurology differences between mammalian species and cephalopod neurology in order to categorize different neuronal structures and different neuronal pathways that might not be mammalian systems, so that way we could potentially use this model as a mechanistic approach of looking at how neuronal circuits could have gone or may mechanistically work from an evolutionary standpoint. So that was really neat. I think it's kind of unorthodox, and I think it's not, and it's obviously can't go well with the translational research in any way, but I thought it was a really cool, neat idea how she could try to backtrack and look at molecular components and apply them to evolutionary neurology. And I think there's a lot of potential. I think there's a lot of potential with that kind of research. It's obviously going to be very expensive and very labor intensive, I'm sure. But if somebody can pull some stuff out of it, I think that would be really cool. Another really cool poster I saw was Global Brain Organization Disrupted in Children with ADHD. And what this girl did is she mapped out the prefrontal cortex of ADHD children versus normal children, and it had them do a go-no-go task, which seems to be pretty consistent for ADHD children, rather than the continuous performance task, which I don't know why. But she had them do a go-no-go task. And she saw that the actual brain physiology itself was the same. It was the pathways that the neurons were firing in the cortex that were different. So that was really cool. That you may have a brain that's physiologically the same, and you may see like similar histone you may see similar histology, but the actual way the brain is firing and the mechanisms and the pathway that the neurons are actually going are different, and thereby, causing different effects. So I thought that was really cool. Oh, and that was by Jessica Cohen from University of Berkeley. The University of California at Berkeley. Another kind of cool poster, but then I went back to the fluoxetine posters. Another cool poster I saw was on fluoxetine on different rearing expressions in depressive-like rats, male rats. And it wasn't, I don't think the guy really found anything conclusive, and his data wasn't super suggestive of anything interesting, other than the fact that he saw a really large weight decrease in the rats. He didn't present on that or anything, but he talked about it, and he was like, oh yeah, I got this really weird weight decrease. I was like, oh, you should talk to this other guy I talked to yesterday who looked at fluoxetine and decreasing weight and due to a leptin, and you should monitor their food, monitor their weight, see if there's a difference between what they're eating and difference between how much weight they're losing. And I thought that was really interesting that that result was confirmed with another student who wasn't actually looking for it. So that was really cool. Another really interesting poster I saw was by Susan Bermaletti. And what was so interesting, her poster itself wasn't on the topic that I was really interested in. She talked about antidepressants and using the forced swim test as a model for that. And what was really interesting was she found that she did a baseline forced swim test, and then afterwards she dosed, and then she did another forced swim test after a long period of dosing. And her results were starting to trend towards significance, and if you had just looked at the final result, you would have been like, oh, those are, trending to significant in a favorable way that we're looking at. But if you look at her initial forced swim test that she did to baseline everybody, the animals were kind of already looking that trend already, and so if you normalize it, if you normalize her second test to her first test, you don't really see any significance at all. So I thought that was really interesting that certain different animals can have different predispositions for this test already before actually even being dosed. So that was a really neat idea, and I think that is going to potentially, if that idea sticks around and continues, I think that could potentially be very, very important for how we go about doing these tests from now on, because we might be able to bring out a certain subpopulation of these animals and say, well, maybe the animals who are already performing poorly in the FST, once we drug them, maybe they do worse, or maybe they do better. It would be interesting to pull out certain subpopulations within one strain to see if there's a mechanistic reason for them doing poorly in the forced swim test, or the tail suspension test, or whatever kind of measure for depression you're looking at. So I think it's interesting that we're often finding in a lot of cognitive neurosciences that there are subpopulations within the certain strain that you're looking at, and I think that has to come from the individual animal itself, which kind of speaks towards the genetics of it and the method and the basic mechanics of it. So I thought that was really neat, and I think it was really good that she kind of addressed this issue. I saw a lot of condition-place preference tests today because we talked a lot about drug addiction, and I saw it a lot being used for pain again today, which was really cool that people are kind of branching out with this model and going forward with it. So I thought that was really neat. And then the afternoon, like I said, was mostly mechanistic based, and they were looking a lot at neuron migration and synaptic plasticity in adults and children, and looking how different pharmaceuticals like morphine, cocaine, addictive chemicals usually, affect the synapse plasticity and the also connectivity of different parts of the area of the brain. So that was really cool. And there's the other guy who was looking at post-mortem human brains, and he was looking at different psychological disorders like depression, anxiety, suicide, those who had committed suicide. He was looking at different neurological plasticities and morphologies within those brains to see if there was a different kind of migration pattern or a different, connectivity of synapses. And he's been finding some really interesting stuff, and he sounded like he was a really cool guy. So I encourage you to look at that kind of work. Other than that, I do have to say that the things that I talked about weren't the most popular. Again, I think the most popular again were basic mechanistics, basic molecular mechanisms of visual pathway and auditory pathways, and how it relates to anatomical sections and connectivities of the brain. I think again those were the most popular. There weren't a lot of them, but they certainly were the most popular. Where there was a whole row on it, and it was just full. Like, it was packed with people, and I didn't understand a lot of the posters. That's why I'm not trying to convey you to the information from the posters. I encourage you to look up visual stuff. I encourage you to look at the visual stuff on your own, and they have it on the SfN application for your phone. But I will say it was certainly the most popular event at the seminar this morning, even though it wasn't the most represented. So I'm kind of glad, because I don't do that kind of work. But at the same time, I'm sure there are a lot of you out there that do that kind of work and really would appreciate more posters, I'm sure, on that area. So if you want to leave comments on, if you do that kind of work and you want to see more representation, leave comments, and I can talk to my people and see, hey, this is what I heard feedback on from the people who watch my videos. Maybe you want to try to give more space to those who do visual connectivity work, or visual mapping and auditory mapping and sensory stuff. So yeah, that was all I want to talk about today. And I know the videos are getting shorter and shorter because I'm getting more tired and more tired as the week progresses. And tomorrow's video will probably be really short because I have to fly out pretty early tomorrow in the afternoon. So I hope you all have a lovely Tuesday, and I'll see you tomorrow. Bye!